Let's do the last three. Please, if you forget this, I'm going to cry. I'm going to cry. Are you telling me that you can't do the square? It's the sum of the squares. Then here you first sum, you square outside. Then you divide by n. Then you divide by n. Look, and it's all inside this one big bracket. How could you forget that formula? Please practice it. And for here, instead of x, you're putting wf. But if it's an x squared, it will be a w squared f. It's not w squared f squared though. Okay, you don't square the frequency. You square the middle value, okay? And then you multiply by frequency, how many there were. And you only add that. So look what you're going to do. You're going to make a table. This thing, these x squared should have a value. This should have a column in a table. X squared we are going to have, we'll be having x values. Then we are going to have values of x squared. We list them all after squaring the x to get them. Then we are going to put their total quarters. And their total is what we are just going to come and put here and here. Okay? This is going to put the total of w squared f squared, which means we're going to need x, then we're going to need w, then we're going to need wi, fi. Okay? Then we are going to need w squared, we're going to need w squared, and then we're going to need w squared, we're going to need w squared fi. Then we will now come and put it in here, and then blah, 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 blah. Okay? And then we'll also need this wf, which we'll come and put at the top. We also need wf, okay? Which we are going to come and put here. The sum of all the wf's, and then we'll square that sum. So anyway, we'll see in practice with practice. But you must be able to do this. Okay? Squared and then minus the sum where the squared is outside divided by n. Now the next thing is the last three, or the last four rather. The first one is going to be the standard deviation. Oh, how simple this one is. The standard deviation, what a walk in the park. What is the standard deviation? If we say s for the sample, this is just going to be the square root of variance. Okay, then again we can say the standard deviation sigma, it is going to be the square root of sigma squared. This gives us the standard deviation. Okay, this gives us the standard deviation. Now once we have the standard deviation, what is the other thing we need to know? The coefficient of variation, which is going to be the CV, okay, CV. This is the coefficient of variation. What do you get? You should know that coefficient of variation is a percentage. It's a percentage, okay? That is why it's going to be important. You're going to see when we interpret that it's a very important thing simply because it's a percentage. So there are still some other things to add to here, but the first thing we should do is at least know how to calculate these things. Then we're going to start to add one by one some other parts. So how do we get this coefficient of variation? We can get coefficient of variation of a sample, and this is just going to be equal to the mean over the standard deviation. So it's going to be, or vice versa, I'm sorry. Standard deviation, which is going to be s, divided by the mean, then you multiply by 100%, okay? It's the standard deviation over the mean, not the mean of the standard deviation. No, it can't. It's the standard deviation over the mean. Then we can say the coefficient of variation of a population now. We are doing of a population. This is going to be equal to what? The mean, which is sigma, over the standard deviation. So the mean, which is not sigma but mu, over the standard deviation, sigma times 100%. Then this is going to give it. So this is coefficient of variation. Then the last thing now, instead of coefficient of variation, is going to be the mean absolute deviation. Let's talk about this guy. Mean absolute deviation, and then we'll talk about the median absolute deviation. So I want you to know that when we talk about absolute deviations, remember this, it's going to be a two-step thing. Absolute deviation, you are going to do two separate processes. If it's going to be the mean absolute deviation, the first thing you do is find the absolute deviation, then you're going to find the mean. If it's the mean absolute deviation, you find the absolute deviations, then find the mean of that. So what do we mean? To find the mean absolute deviation, if you see, this is the shortcut is going to be MAD. So MAD is for mean absolute deviation. And what we put as the formula written down, the formula which you're going to write for MAD, what is it? Is just, if we put it as going to be x minus x bar, then we put modulus, we sum all of them, okay? We are going to say it's going to be the summation of what? Of the modulus of x minus x bar okay, and we divide by n. I want you to know what this is just saying, from 1 up to n. This gives you the mean absolute deviation. All it's saying is do two things. Is the mean absolute deviation? Yes. So do two things. The first thing is subtract all your x values. Subtract the mean from them. Isn't you want to get the mean absolute deviation, right? So first of all, subtract the mean from all your x values and write the answers down, okay? So x1 minus mean, and do it in modulus. We are only taking the value, we only take the positive value. Even if it's a negative answer, we change it to positive. We are taking the modulus, the absolute value, right? Of all the numbers, we are subtracting mean from them. Then when we are done, we get mean of the answer. That's why you are seeing us saying you add and divide by n. So for mean absolute deviation, you do two things. You subtract the mean from all your values whilst you have modulus sign. Then you get the mean of the answer. You subtract the mean of all the value from all the values. Then you're going to get the mean of the answers, okay? You list all the answers down, then you get the mean from them. In other words, you add all of them, then divide by how many they are, okay? Then you're going to have the mean absolute deviation. What about the median absolute deviation? It's a very similar thing again. Median absolute deviation. We saw from mean absolute deviation what it was. It's the mean. You say every x minus the mean, then you're going to sum them and divide by how many they are. In other words, you're going to take the mean of that result, okay? Now for median, we just say median absolute deviation, which we call mid. Mid is for median absolute deviation. This is going to be the mean. So for median absolute deviation, this is going to be the every value you're going to say is going to be, we say it is the median of, then we put bracket, we say x minus x bar modulus, or x minus x bar, which is the median. Okay, median. So it's going to be this of x minus x bar of all is the median of x minus x bar values. Okay, you can say that. So what you're going to do is you're going to say x minus x bar for every single term. You say x minus x. It's going to be x minus median. You say x minus median, 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 x minus median. Then you record all your solutions, right? Then you're going to put them in order of increase, the order of size. Then you're going to get the median of those values. So for mean absolute deviation, what did we do? We subtracted the mean, then we got the mean of those solutions. For median absolute deviation, what do? You subtract the median from all your x values. And then you're going to get the median of those values that you get of that answer, okay? Mean absolute deviation, do two things. Number one, subtract the mean from all the values. Then number two, get the mean of the solutions. What about for median absolute deviation? Subtract the median, my friend. Subtract the median from all your x values. Then list them now, then get the median of the solutions, okay? Then you're going to have the median absolute deviation, and you are done. You are done. This is where, these are the measures of dispersion that are coming in the test. They say the measures of dispersion, we must be able to do all of them without even thinking twice, okay? Without even thinking twice. Now we're going to go to solutions, and we see how good we are. And we're going to have to interpret. Okay, we're going to want to interpret. Now, just when you want to interpret, let's just say they say which value you get. You have two values. You have calculated these things for two things. Then they say which one will have the higher average return. So once they talk about average return, it's not going to be on these values, the variance and whatever. Once they talk about average return, you look at the mean. But once they now talk about consistency, then you're going to look at coefficient of variation. If coefficient of variation is low, then we know that the marks are consistent, or whatever you have is consistent, which means that they are very close to each other, okay? Then when you have the coefficient of variation being large, then you have a problem, okay? The coefficient of variation being large, it means that they are not consistent, or there's going to be changing there, okay? We'll see how to interpret and write proper answers in the videos that are coming. Goodbye for now. Let's meet in the next one.